Then I will share my screen at least. Oh, let me get this started actually.
Kristen, are you okay if I stream this on YouTube as well?
Sure.
Perfect. All right. That's what I was doing. I was clicking the buttons to log
I don't
us
know
in.
how you do that, but if you know how to do it, you do
Yeah,
it.
we had to figure it out because we posted a public Zoom link one time and it didn't turn out too well for us because everybody joined the public Zoom. Uh and so we had an issue. And so
Okay.
we can limit we can limit a little bit of it whenever we're on Zoom or on YouTube. All right, just a second. I'm gonna see if well, I can see you now. Hang on a second. That wasn't the button I wanted. There's all right, there's that. All right, just a second. Oh, it just swapped again. Oh, weird. Okay. They keep changing Zoom on me.
Uh-oh, all rise.
Thought there was a way to go into like dual screen mode. Oh, all right, we're gonna do that, and then we're gonna do this. All right. I think we're sort of live. Chuck, you still around?
I am.
Can you see the screen good?
I can. I can see the women in astronomy, and I can
Perfect.
see Christine.
Yes, perfect.
Kristen.
Yeah.
Good deal. All right. Well, okay, I'll go and get started. All right. Hi everybody. Thank you for coming to this month's member meeting. Um, let's see. This month, I'm excited to bring on a friend of mine, Kristen. She's known as the Astro Ranger. I met her while I was out at Green Bank, and she's got a pretty cool history and background. And her talk that she gave out there was probably a version of this one, and it struck me as, this is pretty cool information that not everybody knows. And so I'm happy to bring Kristen along and let her give us a chat. Thank you, Kristen.
Thank you. Yeah, we had a good time building rockets out there, right? That was my favorite part of the weekend, I think.
It was pretty fun.
Well, thanks for coming out to listen to a talk about women in astronomy from a woman in astronomy. My name is Kristen Hindershot. I go by the Astro Ranger. I let's see. Forget if I put my title screen in here. No, okay. I don't have a picture in there, but a little background is I've been an astronomer my whole life. I don't know when it started, honestly. But I did study astronomy, physics with astronomy math minor in college. And I went into the National Park Service. After college, I worked for probably 12 years, I think. I left the Park Service a few years ago, but when I was in the Park Service, I was doing astronomy programming, and that's where I got that name, the Astro Ranger. Um, now I'm in HR because can't really move up too much or make much of a career doing astronomy programming in the Park Service. But I always say astronomy is my part-time job that I don't get paid for, but I really love to do anyway. I'm currently working on several astronomical league programs. Herschel is my biggest hurdle. I'm just over 200 of the 400 objects found in Herschel, and I do it all with my 10-inch Dob by star hopping. So that's why it's taken so long. But tonight we're here to talk about women in astronomy. And if I were to ask people to name astronomers, most people would probably name male astronomers. If I were to ask to name some female astronomers, I think most people would have a harder time naming any women in astronomy. And that's surprising because this list here is a list of contributions that women have brought to the field. There's a Nobel laureate for black hole research, the discovery of the Cepheid variable, period luminosity relationship, determination of stellar composition, classification system for stellar objects, discovery of the observational evidence of dark matter, first radio evidence of pulsars, lots of comet stellar object discoveries, leaders in exoplanet research, and leaders in the field of searching for the little green men. And why is it that we don't know those women as well? We don't know their names. A lot of us can't place a name or a face to any of these items. Well, one obstacle to the success for them is there was a lot of a lack of opportunity for a long time. It was considered a dangerous experiment. Literally, I've seen that written in old newspapers. A dangerous experiment to educate women in universities. So in about, I would say, the mid 19th century or so, we started opening more colleges where women could attend, but a lot of that stayed separate. We all know the saying, though separate is not equal. When you're splitting resources, one group might get more, and the men tend to get more of those resources that help them succeed a little better. So eventually, Ivy League schools started opening sister schools. Harvard Annex became Radcliffe College. I think most people know that name. It's a pretty common name. And then Ivy League started letting women into schools. Cornell opened co-ed. University of Pennsylvania didn't let women in until 1914. Harvard was around World War II. Princeton and Yale, 1969. Brown, 1971. Dartmouth, 1972. And Columbia, 1983. So finally, it got to a point where women could be more commonly introduced into the education field in equal situations as men. Another obstacle to success for a lot of these women was and is misogyny. And there's a lot of negative that can come with that. But that could be a whole nother program. I don't want to harp on it. So I instead just want to talk about these two comics, bit of a comic relief, but that do show serious sides of being a woman in astronomy. On the left, you have Caroline Herschel. Most people know her, but we'll talk about her later also. She was from Germany, moved to England. She had a German accent. The bottom of that says, the female philosopher smelling out the comet. It was from 1790, I believe. And they have a comet I put in quotes, up in the left corner that is like a cherub. And the comet is coming, the tail of the comet is coming out of the rear end of the cherub, and they have her smelling the comet out. And she says, what a strong sulfurous scent proceeds from this meteor. So it looks kind of funny at first. It looks pretty benign, but you look a little closer, you see they've kind of messed with her English a little bit because she was not her first language was not English. And they also put a big red spot on her face because she had smallpox as a child and had scarring on her face. So not really taking her too seriously as what you'll later learn as the first professional female astronomer. On the right, this actually is a little more modern, describes my experience in college. There's a woman presenting her research, and a man comes up and says, she says, would you like to hear more about it? He says, sure. As she describes her research, he keeps interrupting, saying, how is that different than so-and-so's? She says, well, it's not, and then gets interrupted, but it's just like so-and-so's. And this goes back and forth until another guy comes up and says, well, actually, it's not like so-and-so's. And then he believes him, and then they start to discuss her research without her involved. I think this is kind of funny when I first saw it because it was also true. In that this is very common, or it's not a daily occurrence kind of thing, but I'd say when I was in physics, as an undergraduate physics student, one of the few women in our year in our field this was every couple of weeks, something like this would happen. So it was an annoying side of things we had to deal with that involved misogyny. Another obstacle is just gender roles. There's some statistics here from Gallup and Girls Who Code. 85% of boys are interested in STEM compared to 63% of girls born between 97 and 2011. Girls Who Code found that 74% of middle school girls express interest in STEM fields, but only 0.4% of high school student girls pursue that in college. When they do surveys of um, of kids and young women and men, they find that girls are more likely to think they won't be good at, they don't know enough about, and they don't have time for an education in the field of STEM. And the thing on the right is from Harvard, where it says women with 8 years of programming experience are as confident as men with 1 year of programming experience. And I can speak to this personally. It took me a long time to find my confidence. I think not till my 30s did I find confidence in the field of astronomy. And this is talking about programming, but I feel like from the women I know in scientific fields when I was in college and while I'm in astronomy, I see it all over. Most women tend to have less confidence in the field than men. Of course, this is a generalized statement, but it's definitely a hindrance and in more women joining the field and succeeding in the field. Another issue that arises, let's see, American Institute of Physics did these surveys, and this is 2011, 2010, so it's a little dated, but it's the, this latest information I could find. They did surveys for people with PhDs in physics fields, including astronomy, where they found that number of promotions, number of publications, number supervising undergraduate students, and having enough office space tended to be equal between men and women. But men were more likely to be invited as a speaker, act as a manager, act as a journal editor. Supervised graduate students have enough funding, have enough equipment, have enough lab space, have enough employees. These are all extra walls that women have to deal with in the field of science and physics here. And then on the right, it shows that women have to sacrifice career for family much more often than men do. It shows that women are much more likely to relocate for a spouse, decline a job for a spouse, have a career break for family reasons, become a stay-at-home parent, choose a less demanding or more flexible schedule, change employers or field of employment, and spend less time at work, all because you have a family at home. Again, generalized statements, right? Some men do this too, but what they're showing is that more women have to deal with these walls. I'll show this really quickly because I like the next slide a little better, but this is just showing women in astronomy over the years. So in 1972 to 2017, just look at the overall trend here. On the left, you have bachelor's degrees earned in astronomy. On the right, you have PhDs earned in astronomy. There is an overall trend upward, more women in the field. But I like this graph a little better, showing from 1981 to 2016, the percentage of women in each of these sciences, all of the major sciences. The top line is orange. The orange line is biology. Women are about 53% of the field in 2016. The next science with the most number of women is chemistry. And then the third is astronomy. So they're not too far behind, at least in 2016. And you can see it goes up and down here and there. But astronomy stays kind of in the middle there. There are more women in there than engineering, computer science, and physics, which is my field. These actually are PhDs earned in these fields. I think this is good. We have extra walls to break through, extra issues to deal with, but the overall trend is that more women are joining the field. And that means that those extra walls, that once some women break through them, it's getting easier for the ones to follow behind. And some of the women who started that, well, the first woman that we know of on record of being an astronomer was Hypatia. And she was in the first century, lived in the first century. She was educated by her father, who was a mathematician and an astronomer, and she helped him with his work, charting celestial bodies. Um, excuse me. She helped him in education, so she would educate other astronomers and scientists of the time. She also invented the hydrometer, which measures the density of liquids. You have to remember, though, at that time, there was an Earth-centric model of the universe, so they might have been a little off on their charting and on their mathematics, but she did start to pave the way for women in science. So we're at the first century. We're going to jump to the 17th century for the next woman to leave a major role behind in astronomy, and that's Maria Kuntz. She's a German-Polish astronomer. She wrote the Urania Propitia, and it's a book where she simplified, interpreted, and corrected Kepler's work on orbital physics. This book helped to lead to a German scientific language, and at the time this book was used as a reference for other astronomers. This is the only statue that exists of her in her hometown in Poland, what is now Poland, at least. And the next person in line is Maria Winkelmann-Kirk. Now, I'm not German, so don't critique me on that pronunciation. But she was a German astronomer who married a gentleman named Gottfried Kirk. He became the royal astronomer in Berlin, and she basically became his assistant. In 1702, she was the first woman to discover a comet. Now, at the time, what they would do is he would sleep and she would observe. She would sleep, he would observe at night. So one night she was observing, she finds this, but her husband took the credit for it for a very long time because it would have been scandalous to let people know how much a woman was working in the field of science at that time if they let people know. But she was allowed to stay around and help out, basically. Her husband died in 1710. She petitioned the court to stay on as the royal astronomer, but of course, due to her sex, she was not allowed. But she was allowed to stay around to help here and there. And her career ended when they determined she was too prominent in public life, especially at public functions. And if they had let her become the royal astronomer, she would have been paid for her work and would have been the first woman to have that accolade. Instead, that accolade goes to the next woman, Caroline Herschel. This is the female astronomer who I think most people know. At least they know her famous brother. She was born in Germany. Her brother, a small guy named William. I don't know if most people know him or not. William got a job in England to work on the royal court as an astronomer. She was able to come with him, help him build telescopes, help him observe. She observed one night, she was observing on her own one night, discovered a comet. That got the attention of the royal court, where the king said, you can pay her as an assistant. And that's where we cross a line in history, where now every woman we talk about after her is going to be paid for their work. She discovered 7 more comets, 10 deep sky objects, and she was the first woman to receive the gold medal, the Royal Astronomical Society. It took till 1996 for the next woman to receive that award. Mary Somerville was the first scientist, and I'll get to why we call her that in a moment, but she taught herself astronomy and mathematics. She had a supportive father, I believe, or supportive first husband. I can't remember, but there was a man who helped her to keep on this path. And she wrote, she was, she also taught herself French. She then was able to translate the work of Laplace, all the mathematics, and then she was calculating the orbital period of Uranus, was noticing there are weird things about this. It's not where it should be. And from that, she figured there was something else out there, some other massive object playing on this. She was one of several at the time to predict this. That helped to lead to the discovery of Neptune. And she has the term, she gets to be called the first scientist ever because at the time men were in these scientific fields were called men of science or philosophers. But they all had terms that at the time people thought of as gendered as male. So they had to come up with a new term for someone in science who was female. And a journalist at the time was writing a story about her and another scientist and determined that scientist was the correct term for that. She has a sister school of Oxford University named after her, Somerville College. And she's the only woman that we talk about tonight that's on legal tender, as she's on the 10-pound Scottish note. We're going to jump across the pond and we'll talk about Maria Mitchell. She lived in Cape Cod, Nantucket, somewhere around there. I think I don't know that area very well, though I drove through once. There you can take a ferry to the island where she grew up and she spent a lot of her years. And that's on my bucket list. She's the first professional female astronomer in the US. And she is self-taught. She also had a father who was prevalent in the field, and he helped her learn this, but she did not go to school for it. She did not go to college. But she did discover a comet in 1847. That kind of put her on the map because even in, I think she got it's some gold medal from Denmark because of discovering this comet. She's the third woman to do this. But the biggest thing she got from this was that it gave her a name that people knew, and then she became the first faculty member of Vassar College. Though not the first female faculty member, the first person hired to teach at Vassar College. And there she also became the observatory director. In that time, she was a pioneer of solar photography. She discovered that sunspots weren't just clouds, as what they determined previously. And her biggest legacy she left behind is that she educated hundreds of women behind her to get into the field or at least learn the scientific language and be able to be successful in their own right. We're going to jump back across the pond just for a moment, talk about Wilhelmina Fleming. She's the first of four we're going to talk about here that are Harvard computers. She's Scottish American because she lived in Scotland. She was born there. She moved with her husband to Boston when she was pregnant, and he left pretty quickly. She had to find a job. And so what she did, she went to Harvard, to the observatory director, Edward Pickering, and asked for a job. And he hired her as a maid. His wife determined, well, she's pretty bright. You should actually use her as a Harvard computer. And that's when she got hired on to do that work. If someone out there doesn't know already, Harvard computers are people who basically are analyzing data. It's a lot of tedious work. You got to use good eyesight and sit for hours staring at glass plates of images of stars. And Edward Pickering actually determined that women were best at that job because they made less mistakes, they were good at this tedious work, and that men were better at the jobs of operating telescopes and withstanding the cold at night, in his words. She worked for 30 years on this, mostly on stellar spectral analysis. She discovered some novas through spectral analysis. She also discovered 59 nebulae, over 300 variable stars, and in 1888 discovered the Horsehead Nebula. In 1898, she was appointed curator of Harvard's astronomical photographs, which is important because these photographs are used by the women that follow to make big discoveries. Annie Jump Cannon is one of those women, another Harvard computer. She went to Wellesley College, another sister school. She's an American astronomer who also worked on stellar spectral analysis. She determined the classifications. She kind of simplified what was already in place through Pickering and Fleming, and determined that it should be by temperature into classes of O, B, A, F, G, K, and M. In 1922, the International Astronomical Union adopted that into universal use, and we still use it today. So that's basically saying the O's are the hottest star, the M's are the coolest, and our star is a G. She discovered over 300 variable stars and 5 novae in all of this time she worked. She was actually the first woman hired at Harvard Observatory who also operated telescopes, because she was trained in that from when she went to college. So she did both computing and telescope operation. I don't know when she slept, honestly. She also received the first honorary doctorate from Oxford for a woman. And another Harvard computer. This is she's one of my favorite female astronomers in history. Henrietta Swan Leavitt. She graduated from Radcliffe College, another sister school. And she worked on determining the brightness of stars. She became the head of the photographic stellar photometry department pretty quickly when she was working there. She had a short life. She only lived into her 50s, I believe, young 50s. But in that time, she was able to develop a standard scale to measure stellar brightness, and that was used for a while until technology improved. She discovered 4 novae, thousands of variable stars, but her biggest legacy comes from discovering in 1912 the Cepheid variable period luminosity relationship. It's a mouthful. And we use that as the first standard candle to determine distances outside of the Milky Way. And in case, I know we're all astronomers, I believe we're all astronomers listening. In case someone doesn't know, I'll describe quickly. Cepheid variables are variable stars that change brightness over time. And what she determined was that this type of variable star, that the longer it was bright, the brighter it would get. So if you can measure the length of brightness of this star, you can then determine how bright it should be at its peak compared to how bright you see it. And from that, extrapolate how far away it is. This was used by Edwin Hubble, maybe one of the most famous astronomers of time. He used it to determine that there was a Cepheid variable he found in the Andromeda Nebula, which is what they thought was at the time, it was part of our galaxy. He was able to determine that that variable was over 2 million light years away. So there's no way it was in our galaxy. And from that, found that the Andromeda Nebula was actually an entire galaxy on its own and became the Andromeda Galaxy. He discovered many more Cepheid variables, was able to take all this data and figure out that how far away things are using redshift and of stars also, but through all of that, be able to determine that the universe is expanding. And none of that would have been possible without Henrietta Swan Leavitt's work. Cecilia Payne-Gaposchkin is the last woman we'll talk about as a Harvard computer. These four women are not the only ones. There were many women who worked in that field, but these are just the ones that made the largest impact. She was born in England. She attended Cambridge University, received undergraduate there, but Cambridge would not allow a PhD program for a woman, so she traveled across to Boston. She got her PhD from Radcliffe College. Technically, she got her PhD from Harvard because she did all of her work at the Harvard Observatory with Harvard, a Harvard, um, can't think of the word for it, the person who's guiding you when you're a PhD student. um, Harvard would not allow a woman also to have a PhD at the time, so they had to put it in the name of Radcliffe, their sister school. But that's where she worked as a Harvard computer to get her PhD. But she stayed on at Harvard to become a full professor, the first woman to to chair a department at the school, the astronomy department. In her 1925 thesis, she was the first to discover that stars are made mostly of hydrogen and helium. At the time, people were saying that maybe they were like equal parts of many types of gases. Um, and this kind of threw some people off. The Princeton Observatory director was said that, well, this is just wrong, because he was very stuck in thinking that it should be equal parts of all of these gases. But in time, other people found the same conclusions, and so she was proven right. She observed, with the help of her husband and um, lots of other Harvard computers that worked under her, she observed millions of variable stars. All of that data was able to come together to determine paths of evolution for stars also. Nancy Grace Roman. This is a name that will become very popular if it hasn't already started. She is an American astronomer who earned a PhD from the University of Chicago in 1949. She discovered that stars are made of hydrogen and helium, that are made of hydrogen and helium, move faster through space than those made of heavier elements. She found a UV excess method that was used by other astronomers to determine which stars were heavy element stars. But her biggest legacy comes from being the first female executive at NASA, where she created the space astronomy program. She gets the title of Mother of the Hubble Space Telescope because she really pioneered that field in putting astronomy science into space. And she was a major proponent of getting that telescope into space. And because of that, her name is going on the next great NASA telescope. That is going to be called the Nancy Grace Roman Space Telescope, or what I assume, as we do with the Hubble and the Webb, we'll just call it the Roman. And it's going to, I think 2027, last I heard, will be launched. It's also working on exoplanet research, because this will be more infrared, also a lot like Webb is. Exoplanet research and researching dark matter, dark energy through gravitational lensing. Her biggest thing, though, is that she was made into a Lego form. She is part of the Women of NASA series, and I have this sitting on my bookshelf near me. Um, she's it's like maybe a $40 kit, but they don't make it anymore. So if you can find it, you have to go to eBay now. You can't go through Lego to get this set anymore. But it is a cute little set, and she'll be immortalized forever in this form. Another woman astronomer that I fangirl over a bit is Vera Rubin. She's an American who, in 1948, was the only astronomy major to graduate from Vassar College, a sister school. She earned a master's from Cornell, where she took classes from Hans Bethe and Richard Feynman, some of the best minds at the time in physics, so she was trained well. She got a PhD from Georgetown, and then she stayed on at Georgetown to become a professor. She was the first woman to observe at the Palomar Observatory, and her biggest legacy with Kent Ford, they discovered that outer stars and spiral galaxies rotate as quickly as those in the center. And again, some of you probably already know this. In case some of you don't, this breaks Newtonian physics. Things on the outside, stars on the far reaches of a galaxy should rotate slower than the ones directly in the middle. If all of what we see is all the matter, all the mass. But since they don't, they rotate as quickly as the center as the outside and the center. They rotate equally. It means there's a lot of mass we can't see within galaxies. And then, hence, she discovered the first observational evidence of dark matter. She won the National Medal of Science in 1993. Her and Kent should have won a Nobel Prize, in my opinion. But she does get a dark dark energy telescope named after her. And that's going to open up in Chile next year. It will image, it has the largest digital telescope in the world, and its job is to image every bit of the observable sky that from its location to an extreme resolution. It's working on dark matter, dark energy. It's also tracking near-Earth objects that have the potential to have damage to the Earth if they should impact the Earth. So it should discover more near-Earth objects. I think it's objects that are 300 meters and larger. And the biggest thing from this telescope is that so far what they say is all the information should be public. And that means who knows what other discoveries are going to come from this, what other scientists are going to use that data to make huge discoveries in the field. And we're going to jump back across to England to talk about Jocelyn Bell Burnell. She had received a PhD in Cambridge in radio astronomy. While she was there conducting her research in quasars, 1967, she discovered a series of extremely regular radio pulses. She brings it to her advisor. Advisor was the word I was trying to think of earlier that I was blanking on. And they joked that it was just LGM or little green men. But in reality, her advisor was Anthony Hewish, and he really thought it was something man-made or some kind of background noise. It wasn't anything important. He would then have meetings with other people, leaving her out. She kept persisting too, saying, I keep finding this. It's not going away. It has to be something. And eventually I figured out that she had discovered pulsars. In case they don't know what a pulsar is, they're like lighthouses in space. These are very densely packed stars that are rotating extremely fast, and they shoot pulses of radio energy out their poles. If one of those poles passes or points at Earth, we get a radio pulse. And this can happen at this will happen at very regular intervals. And that's what she found. Hewish and a gentleman named Ryle, who built the telescope she worked on, actually won the Nobel Prize for that discovery. She did not. The reasoning at the time was because she was a graduate student. But since then, other graduate students in physics have won Nobel Prizes for their work while being grad students. She also served as president of the Royal Astronomical Society, the first woman to do so. The first person to do that was William Herschel, so she was in great company. And she received the Copley Medal in 2021. This is the most prestigious scientific medal in the UK. She's only the second woman to receive it. We'll talk more about those little green men with Jill Tarter. She's an American who graduated in 1966 from Cornell University. Her maiden name is Cornell because she's a direct descendant from one of the two people who established the university, but whose name is on the university. She, at the time, they used to give away free, like you could go to school for free if you were a descendant. By the time she went to Cornell, they were giving scholarships instead for direct descendants. So she applies for this scholarship, and then they tell her, well, actually, it's only male descendants that get these scholarships. So she had to go find her own source of funding in order to attend school in Cornell, but she did. She graduated in 1966. Then she earned a PhD in 1975 from the University of California. In her PhD dissertation, she coined the term brown dwarf for a star that's somewhere between a Jupiter and a small star. And afterwards, she helped establish the SETI Institute, so the Search for Extraterrestrial Intelligence, in 1983, and she became the first director. She became a pioneer in this field, a leader in the search for extraterrestrial life, something that a lot of people thought was a waste of time. You're never going to find anything, and we haven't found anything yet, but she was determined. And if you've ever seen the movie Contact, you have seen Dr. Eleanor Arroway, who was inspired greatly by Jill Tarter. Contact was actually based on a book by Carl Sagan, written in 1985, which is my favorite book. And I think, most people say this about movies, but the book is better only because it just adds more information. But she was the drive behind Eleanor Arroway really fighting to keep observing through radio telescopes and searching for extraterrestrial life. Now we're moving on to women who are still working. Jill Tarter is alive, but she is technically retired. I'm sure she still works sometimes, but technically not working anymore. Sarah Seeger, on the other hand, she's a Canadian-American astrophysicist and professor at MIT. And she is an exoplanet pioneer because she was the deputy science director of the NASA mission TESS, which is the Transiting Exoplanet Sky Survey, I want to say. I know the first two are right. She was the director for the first part of that mission. TESS is still in operation. TESS has discovered something like 400, at least 400 exoplanets and hundreds others that are candidates that need more observations to determine if they are actual exoplanets or not. And her work led to the first detection of an exoplanet atmosphere. She also is called NASA calls her the astronomical Indiana Jones. And that's because she's searching for the Holy Grail, which is another Earth-like planet out there. She hasn't found it yet, or she's found some that are close at least. But she's still out there working. She has won many awards, including the MacArthur Genius Grant in 2013. And just remember her name because exoplanet research is hot right now. Most telescopes being built, large telescopes. If it's not their main mission, it's at least a side mission to be working on exoplanet research. So it's a big thing. They're really out there trying to find that other place where life might live. Life might be able to survive. And we're talking about Andrea Ghez now. She's the last woman on my list for the night. And that's because she has left the biggest impact in the field of astronomy. She received a PhD from the California Institute of Technology in 92. She became a professor at UCLA in 94. She won a MacArthur Genius Grant in 2008, and that's pretty big, but nothing compared to that she won the Nobel Prize in 2020. She was the first woman in astronomy to win this prize, the fourth woman in physics. And I had to go through the whole list of all the people who have won Nobel Prizes and find every astronomer in the list. So I might be off a little bit, but I counted 27. So I'd say 27 plus or minus two, just to be safe. Men have won this in the field of astronomy before her. She worked with a gentleman named Reinhard Genzel. They did not work directly with each other, but they both discovered the observational evidence of the black hole in the center of our galaxy. Of course, it was theorized it was there before, but they used the Keck telescope to observe at infrared wavelengths and track stars that were orbiting around Sagittarius A star, which is what we call our black hole, and was able to determine that, yes, there is a black hole there, and it's 4 million solar masses large, making it a supermassive black hole, which makes sense for being in the center of a galaxy. With more research, they've determined that most galaxies have supermassive black holes in the center. She has won a huge award. Her name is big in the field. And she knows that that means a lot of people are going to look up to her. I look up to her. But definitely children, girls and boys can aspire to be like her. She definitely worked hard. She had to persist a lot through this research because, as she put it, it was difficult. You had to keep plugging along and finding new ways to solve problems, and doing this for years for it to pay off, decades to pay off. So I like to leave the program with the words of Andrea Ghez, where she says, "It's always been very important to encourage young women into the sciences. So to me, the Nobel Prize means an opportunity and a responsibility to encourage the next generation of scientists who are passionate about this kind of work into the field. It's important to have role models. I think seeing people who are different succeeding shows you there's opportunity there, that you can do it, that this is a field that is open to you. It's often hard to do things that are different, and if you're already different, there's opportunity as long as you have the confidence to do things that are indeed different." And I leave you with this picture of the Harvard computers. This is at least before 1920, probably around between 1915 1920. The paper doll image, they call it. And the woman, 1, 2, 3, 4, 5, 6 from the left is Henrietta Swan Leavitt. Third from the right is Annie Jump Cannon. Does anyone have any questions or comments? Want to add anything?
Well, first, thank you very much. Does anybody have any questions? I have one real quick.
Yeah.
The Harvard computers, when did that official moniker shut down? Like, do you have any idea on the timing of that?
I'm glad you just mentioned that, because I forgot to mention there's a good book to read about the Harvard computers called The Glass Universe. I wonder if I can type it into the chat. Oops. I'll try to type it in the chat, but
Okay.
Glass Universe by Dava Sobel. It's I have gotten like 3/4 of the way through it. I don't remember specifically when it ends. But definitely goes through a good part of the early 20th century. And
Gotcha.
it started in the late 19th century.
Gotcha.
I was really interested in the slide that had the number of undergraduate astronomy degrees because I had no idea I was one of so few. 1981, baby.
I wonder if I was gonna say, I wonder if I can go back to that, but it's a long way back there.
That's okay, but I just, that was fun to see.
So you were one of the PhDs?
No, just an undergrad, but.
Okay, undergrad.
And I
Great.
was the only woman, of course, there were only two of us that year that got astronomy degrees at Case Western anyway, but there was one lady that was in the physics department, which was bigger, and then there was myself in the astronomy department. And
I had to go back.
yeah, you didn't skip class. Yeah, the bachelor's degree was there.
So look at you down here. You were way down here compared to the
Under 50,
number
yeah.
of people in the field or getting bachelor's degrees at the time. That's awesome though.
Talking about those graphs, flip back to
Oh,
the one
yeah.
with all the STEM. So I teach biology. So next slide. So I teach biology, and I can tell you that women in biology is strong.
Yeah.
And it's great, right? Like, because we really started pushing STEM, and I love that you're seeing this shift from kind of that what they called it when I was in grad school, the good old boys club of the
Yeah.
biology world, and now I could say that probably 70% of my students are all female, and it's
Wow.
great seeing that shift, and I'm wondering, like, with an update, right? Like, this is, 8 years old almost.
Right.
I wonder how much those numbers pushed, how much difference is, how much difference is trying to promote STEM for younger people and younger women, like how much of an impact that's having and stuff. So it's really cool.
I mean, I kind of see it in the math part of my brain just sees this as overall trends.
Yeah.
And they're all trending upward. There's no reason to believe that any of these have gone down. Maybe some have plateaued. Last I heard, I thought biology was like 55% women in undergrad. I think that's what I heard. Now I could have that number slightly off, but that would show that maybe it's gone up a little bit.
Yeah.
But overall, good trends, right?
Yeah.
For women in the field. And that does make me wonder though, 70% girls, man.
Yeah, it's pretty crazy.
Where are the guys too?
Where'd
they all go?
yeah. Well, that was what, like, some people are starting to worry that they focus so much on, raising women up that they pushed men out, which doesn't make sense. But people are really noticing that in the biology field. It's pretty interesting to see how many women are coming through, and it's great because the more variety and more brains we get in, doesn't matter, male female, but
Right.
yeah, people are wondering if, like, the push was too much and that they kind of, like, didn't encourage men the way that they were encouraging women. And so it was an interesting take because somebody came and talked to our university about that, keeping an open mind,
Yeah.
obviously, without trying to, see sexism one way or another. But it's just kind of interesting seeing those stats.
Maybe it was just like assumed, well, boys are gonna go into the field.
Yeah.
They'll fill it, so we don't have to worry about them. But then
Yeah.
let's encourage these young women.
Yeah.
And then forget about the guys. I can't
So
say that some of
I was
them
gonna
go.
say, so you do a lot of stuff with the parks. Do you guys have astronomy outreach programs for women and young men, or do you guys host any of those?
So I'm a member of NOVAC, the Northern Virginia Astronomy Club. That club has a lot of outreach, and they do, genderless, any children that want help. They have a mentor program where we get emails saying, "Hey, can anyone mentor this young person?" And they'll say like they have a 10-inch Dobsonian or some type of telescope I've never heard of, and they need help in learning how to use it. And they want to be an astronomer one day. So people kind of volunteered in that. The National Park Service, when I was there, we had junior ranger programs. where again, genderless is just whatever kids show up. I would always do junior ranger programs based on astronomy, of course, as much as I could do in daytime programs. But I would always encourage them to come out for the night program with their parents later. It's hard with kids in astronomy. The younger they are, um, the harder it is to get them to come out at night because they have bedtimes, right? And especially, I lived in Grand Teton National Park for a couple years and volunteering there with astronomy outreach. And it didn't get totally dark until like 11:15 in the middle of the summer. And that's when we had our visitation. So kids just very rarely would parents let the kids stay up that late.
On the other side of
Um,
that, we're here in Nashville, and after daylight savings, we're going to be getting dark at 4:30. So
yeah.
that's when sunset is. So puts us in a whole
Well,
different category of that.
it's already sunset at 7:30 right now, I think. Is that right? Or a little less?
Yeah, somewhere out. I mean, yeah, sun was down by the time I showed up here. So
It's
yeah,
kind of surprised me lately.
yeah. Anybody else have any questions for Chris? Yeah.
She talked about velocity around a galaxy where the bands are the same speed as the center.
Mhm.
Is that like an angular velocity, or is it just a real linear, well, not linear, but velocity, the normal, what we would think?
Well, now I do have a physics degree, but it's been a decade and a half since I've used it. But so I'm gonna try to reach back. Um, yeah, it's an angular momentum issue, conservation of energy issue. That the farther out you would be from the center of rotation, the slower you should move.
But they're
Is that?
not.
Yeah.
But they're
Yeah,
not.
okay.
Yeah,
Yeah.
they're
So it's
rotating
like
as
an
fast as the
angular,
center.
uh,
But
Yeah.
and that's not the case for all stars. It's a generalization because there are some stars that GES have found rotating around Sagittarius A star that are extreme speeds, and some of these stars get flung off outside of the Milky Way and other galaxies. This happens, so there are one-offs, but in general, they rotate at approximately the same speeds.
Cool. I have one more, unless anybody else has got one. So the Rubin telescope, you said it's going to be in Chile. You said it's going to be opening actually next year.
That's what they say.
Yeah, who's I guess who's running it, who's funding it, things like that. Is that a joint effort or?
That's a good question. Yeah, I don't know that. I'd have to look it up. Um, I yeah, that's a good
And
question.
yeah, I was also interested in the open access data, and like wondering if citizen science stuff is gonna take part in that, or like what kind of, is it gonna be all zeros and ones or pretty pictures, or like trying to figure out like what we could potentially do with that data.
And that's a good question too. I was always just assuming that it was going to be images. Um, I never thought about maybe it being in another data form, but
Yeah.
it's possible they could be doing multiple things to benefit multiple sciences, right? Some fields might want it a little more broken down. Some fields might. I'm more of an observational astronomer, so all I think about are pictures, right? I don't think about the other side sometimes.
That boring stuff. Well, cool. Well, thank you very much, Kristen. Does anybody else have any more questions?
Curious, for the club, how many, and this is here, we have a lot of women in the club, but not many show up with telescopes on the field. So do you have some number of women that bring their telescopes to star parties and go on?
Well, I can only because there aren't studies out there that I've ever found about this. I can only base it off my own experience. I go to probably 9 star parties a year. In the warmer months, I'm about every new moon at a star party. And a lot of them are ones that I can just drive to around the DC area within 5 hours or so. So I go regularly. And I would say sometimes I'm the only woman on the field. Sometimes there's I mean, maybe the most I've seen is maybe 10 other women. That was probably pretty rare, though. I would say at least 5 other women that are observing on the field that have equipment and they're observing. There are usually other women that are there enjoying. They might be coming with a spouse, or they just want to like lay out a blanket, enjoy the stars and the comfort of and safety of having other people around. Because I know I get a little nervous when I'm by myself in the middle of nowhere in the dark. Um, but yeah, it's not much. I would guess at best 10%. And Tom, you know the I would say StarQuest has the most women.
Yeah. Yeah.
How what would that percent would be for you?
Yeah, I
If you
mean, I'd probably say 25 to 30 there because I mean there was a pretty strong contingent there. Yeah.
there's a
So
lot of women at that one, but on the field observing, I don't see as many, but there's definitely interest from a lot of women at least.
yeah. Yeah. Yeah, we got one more.
Yeah, you mentioned that you were working on your, was it Herschel
Yeah.
one, Herschel 400, I think it is, with the Astronomical League. And you're doing it all observational and star hopping. That's good. It takes a long time. I did mine with GoTo and a schedule,
Okay.
you know, as I went. And what level are you working on right now?
Oh, I'm working towards Master Observer. I have to
Okay.
finish Herschel, finish Double Star. I have like 7 objects left on the urban program. I have to wait for Virgo to come back up. Um, um,
You know, you can do multiples at one time.
yeah.
Same
Tonight,
time.
if it's clear, it was cloudy when I came in tonight. If I get out there, I'll work on my double star and asterism because I can do more of that with the moon out. But I'm pretty close. Then I have to do one more program, and then I will have Master Observer. Are you also Master Observer?
Yeah, I'm a master observer.
Nice.
Several years ago, though.
Okay.
Now, so I'm a little bit slower at doing these things. I'm working on my binocular masters now.
Oh, nice.
And it's a race between my, my, my life, how much time I've got left and getting that program done.
We'll keep
Hey,
plugging.
Take a while.
I wish you the best. Then you just keep plugging away at it, right? And it's fun. It's fun along the way, at
Yeah.
least.
Well, very cool. Well, Kristen, we'll go ahead and let you
Oh,
go. Thank you again so much
Tom,
for
I
Yeah.
did find the Rubin Observatory is going to be National Science Foundation, U.S. Department of Energy.
Oh, cool. Well, that's it.
That's from their website.
Awesome. Well, thank you very much, Kristen. It was great seeing you again and great hearing your talk. Always good to hear some history and realize that there's more people involved than what we taught about and what we think about. So I really appreciate it and thank you again.
Well, I appreciate y'all listening to hear about these awesome women.
Yeah.
And I hope maybe I'll definitely probably see you again, Tom. Hopefully another StarQuest. Hopefully I'll
Yeah.
see everyone else somewhere along the way.
Yeah,
Thanks for having me.
of course. And thank you. All right. Well, we'll go ahead and let you go
Have a
and
good night,
do your
everyone.
thing. Have a great night.
Thank you. Bye.
Bye.
All right. So now I'm gonna wind up mine. See if I can get mine going. All right. Oh, that's why.
Where was this picture taken?
That is a Windows feature where it has a picture of the day. That picture was from where's that?
Those fossils?
Yeah. Fossils of belemnites and ammonites. Let's see. Jurassic period. Sorry, I'm loading up the slideshow. Where'd it go? Oh. Yeah, so I lost my Zoom button. You're still on Zoom, right?
Yeah,
Where'd
you're
it
out
go?
here.
Yeah. Yeah. Oh, there you are. I see you, Chuck.
All right.
Appreciate it. Although you can't see me, so aha. Oh, there we go. All right. Let me get back to here, and then I can go back to there. It's a whole song and dance. All right, there we go. All right, can you see the screen, Chuck?
Yes, I see it.
Perfect. All right. Well, we'll go ahead and get started up today with the official business portion. Thank you again for everybody for coming. We have some cool pictures to look at tonight and some interesting things. If anybody has any questions, feel free just to stop and ask. So this is our monthly member meeting for the month of October. Hopefully everybody had a chance to go through and oh, come on. There we go. Had a chance to go through the minutes from posting the Eclipse from September. Does anybody have any questions on things that were going on in the club? Perfect. Let's see. Member report. I don't think I saw Keith on here. I checked before I came on. We're at 210 in terms of membership. If you haven't paid, Keith might have sent you an email. I remembered today, and so we have $25 more in PayPal. So I did renew, so now I won't get kicked out. But if you need to renew your dues or want to figure out how to do that, come chat with us. Theo's here, and we can get you hooked up with PayPal and whatnot there. Speaking of Theo, treasurer's report.
I want to thank Keith officially because, he sent out a bunch of renewal notices and, oh boy, that's like a quite a way to find. So our total bank balance is $9,802.69. We spent $17.47 for the Zoom account last month and renewed our website for $203.88. So I finally got, I think all of our regular, like some members had those on their credit cards and then I'd have to do that. But now I think we've gotten all where it all comes through club. And so that works pretty well.
Good.
Even though I just emptied the PayPal account, it's got $75.74 again.
You're welcome.
Yeah. There you go. That's good. So anyway, we've gotten some money and a lot of people are new, and that's great. Social media, I want to thank Don again for doing a great job with the Facebook. It's been liked by 2.3K and it's followed now by 2.6K. We've gone up a little bit there. Our X following is now 342. I think I just need to go on there and say something inflammatory.
or there's a comment, it's coming our way.
And I made the mistake of saying, go out and look for it and go out and look to the west. And people go, well, tell me where I should go. I have to restrain myself from not being to let me Google that for you up on the screen. But go west, young man. You walk around, do something radical like go outside and walk around your neighborhood.
Yeah. Well, cool.
And people have been wonderful. This has been very photogenic comment, right? So
yeah,
even phones are picking it up really well. You can just go outside and take a picture, and it's been great.
I'll talk about it later, but this last week we've been kind of blessed. We had the aurora and then the comet. I mean, it's been a crazy year.
Have you all been
Yeah.
you all been able to see the
Yeah.
aurora?
No, I saw the aurora last Thursday. I didn't. Yeah, I'll talk about it in a minute. It was different than May's. Like it was wild. But yeah, we'll get to that here shortly.
Thing I had to add was that I did put out an ask today for interest in the Observer's Handbook.
Yeah, I'll bring that up too. So
Button up, but I think what I'll do also is I'll just put in an order for the over 10, maybe 12 or something like that. They'll show up by the Christmas meeting, and so then, you know, if you haven't prepaid for it, it's just that you're the first come, first served.
good deal. All right. Moving on with the business. We do have a loaner program for people that are for members. We're starting to look at ways that we can improve it, maybe make it like a library checkout system. And so we do have equipment available for loan. So if you're interested in trying out a wonderful Dob or some other type of telescope that you're looking at and wonder how portable it is or how easy it is to use before buying one, come check us out. And we're happy to get you set up so you can observe, see if you'll use it, because that seems to be the best telescope there is, the one that you're going to use. So
Is that an 8-inch?
probably, I would guess so. Yeah. We do have a couple 8 inches with the club as well. And so the list is on the Google Groups, which is part of our discussion board. I'll talk about that later. I know that we have a lot of scopes out. And so if you hear me and you have a scope, let us know how you're doing with it. I'd like to make sure that you're enjoying yourself. If there's any questions, let us know. And especially if there's anything we can help with. There's a lot of knowledge amongst the members here. And if one of us can't help you, I'm sure we can dig around and find more people to help out. Moving into business for next year, I can't believe I'm saying that, but it's already October. I realized that when I was putting together next month's slide or next month's talk is the all I want for Christmas talk. And so like we're 2 months away from 2025 somehow. So we have a couple things that are coming up, which I'll talk more about at the next meeting. We're set up to do voting for the 2025 year. And so there's going to be a cycle of board members. And so if you're interested in running for a board position, we'll have a vote in December. So it's 2 months away. So I'm just putting this on people's radars. If you're interested in running for a position, let us know and we can get that taken care of. And we'll talk about what that means. We're also looking at various Star Party locations. We're starting to set up that calendar because again, we're 2 months away from 2025. So we're starting to look at that. I know that there's been mention of other parks and other places for holding Star Parties. We're starting to put some feelers out, maybe get a little bit more variety and stuff. Talked about maybe trying to get a little bit more south of Nashville as well, because things kind of run over to the west. Yeah.
Will we continue meeting here through the winter?
Yeah. It's a great question. I'll talk to Dr. Billy and see what their thoughts are. From what I gathered, as long as it's not slick, right? Like as long as there's not ice or snow covering, I think we can continue to meet, even though I think they shut down, right, for winter. But from what I gather, they're good with us still coming as long as the roads are passable. Yeah.
At what place?
Here for continued meetings. Yeah. And if something like weather wise does come up, right, like a freak snowstorm comes in, then we'll probably just shift to Zoom, like we had to do for our first meeting here, because as it turned out, we got snowed out our first meeting here. So but we'll send out a message as soon as that happens. We're also I've started looking into setting up speakers for next year as well. I've already got one on the books. He's a astrochemist for NASA, and he works in their astrobiology program. And he was the project scientist for the OSIRIS-REx mission, where they landed on the asteroid and brought chunks of it back. And so he's got a lot of really cool research. Me being a biology guy, he's a biology guy, and they've found some interesting stuff on these rocks that they brought back. And he's kind of locked into the peer review process, and so he can't release any data. So hopefully in a couple months, he'll be able to talk about some of the cool things that he's found in terms of science and biological chemicals and things like that on these cool rocks. So if you have any interest in a specific speaker or a specific topic, let us know. It makes our job easier whenever we can get stuff that you guys are interested in. So we have those kind of things starting to ramp up for 2025.
If anybody really wants to do a newsletter, we have a lovely newsletter that gets sent out every month. And Drew would really like it if somebody else would take it on.
Yeah. If you didn't hear, Drew thankfully is running our newsletter for us, and it is a lot of work along with everything else that he does. And so if anybody likes to do newsletters, likes to put things together, we can, start working with that, and we'd really appreciate any assistance people would give. So all right, and we'll put that on the list of things to do to officially make sure that happens soon. So on with the normal spiel for members and non-members alike. Every time I put together my slides and update my my material, I start to go, oh man, this is it's a great resource to have. We're potentially looking at revamping our website a little bit. Hopefully, things that'll stay standard, like the clear sky chart. I like seeing all that dark. That's pretty nice. I think that had enough clouds for a while, and so as long as they stay away, we're good. Maybe get some more observing. The comet's supposed to be pretty good for next couple days at least, as it climbs higher in the sky. On our website, we have the posters that you can buy with that special hatch show print. They're still pretty cool. Theo, we got about 20 left. Is that what you said? Yeah.
I brought some tonight.
So, they're $20 a pop, or she'll throw them in a tube and ship them to you for 25. They are pretty nifty hatches. If you're a collector, they made that stamp of the telescope at the bottom specifically for us, and so it's kind of a unique, one of a kind item. I guess we'll have to figure out. We're almost at the 100th, right? Like, when was 90th? 2019, 2020? Trying to remember when the 2018. So 4 years away from the 100. So that's coming up quick. On here we have our next member meeting, public star parties. We're getting ready to update that. You can see it down low. And basically some general information on
catch of the super heavy.
What was that? Okay, never mind. Also on here, on the right, there's a Facebook feed for what BSAS is posting. And so if you don't want to click one of the little tabs on the left, you can see what our feed is over here on the right. And like Theo said, Donna has been helping us out quite a bit with Facebook. And so she's been rocking and rolling with that. Speaking of Facebook, we're at 2.3 thousand likes and 2.6 thousand followers now. That's gone up another 100. So we were at 2.5K followers. And so hooray for that. Love the outreach going on. And then this post was, I think, yesterday, where was it yesterday? I can't remember when I snagged this. Maybe this was I think I snagged this yesterday. I can't remember, but this is how the comet's looking throughout the time coming along. We're at the 16th, and so it's third from the bottom. You can see it rising higher and higher in the sky. Imagine it'll start getting a little bit dimmer the closer towards the end of the month we get. So if you get a chance, go out there and look west. Venus and Arcturus are perfect signposts for it, because you find those two and it's somewhere in the middle, maybe a little bit up. You get a nice little triangle out of it. And so they're not too it's not too hard to find once you get Venus in, because you just kind of start looking at about 2 o'clock, 3 o'clock almost. So on Facebook, we've started sharing some pictures. This is Connor, a member of ours. He posted these pictures, so you can see a beautiful tail, beautiful head of it. Yeah, it's a pretty fantastic view there. and we'll get more to the comments here in a second. You can find us on X/Twitter, or X Twitter, I guess. We're at BSAS Nashville there. I threw this, this wasn't our most recent post. The most recent post we've already kind of talked about. But I thought this was really interesting. That they're seeing the effects of light pollution in other areas, that aren't necessarily thought of being, super populated. I was I was kind of interested because I like the biology aspect of it. And so I went through and kind of read what was going on, and they're basically testing out, like, I guess, how well these animals do in light. And so I went through and found this, and basically, on the left is mimicking the blue light that we get with the newer bulbs and the newer lighting, compared to a red light, kind of a softer red. And we know that red light's easier on the eyes because as we're out there observing, it's nicer on our eyes. And there was definitely a desire to be away from that blue light. And now I know this is a controlled experiment and whatnot, but still, I can't imagine what these things are seeing whenever they take flight and they're over a city. And so they're, looking at the concepts behind these light pollution. So if you haven't, started looking at light usage around your home, there are things that we can do to make our own areas a little bit more light friendly, like motion timers. Make sure that your lights aren't on all the time unless you need them on. Make sure your light is properly pointed to where you need it to light up. Things like that can help out. Just starting somewhere is a great place to go for that. So it's always a big push of, one of the things that we're interested in as an astronomy club, because light pollution kills our skies for our observations, but it's also taken a toll on the biological creatures out there. So it's a pretty good project to push for. On Instagram, we see a few images up here. We can see some of the images that were shared on Google Groups. The aurora, we have some comet pictures, a sun picture, Steve's picture of the Ring Nebula there. If you would like to share your images with us, let us know. We'll probably cherry pick some pictures off of the Google Groups to share, because we love seeing your images. If you do have Instagram, we would love to give you credit. So whenever you're posting a picture and you would like us to share it, make sure you have your Instagram handle, and so we can give you credit so people can find your awesome work. And if you have any images that you would like to give us or send us, you can send it to info@bsasnashville.com, or just post it to the Google Groups, and we'd love to kind of show off your work. Speaking of the Google Groups, we are here. I took a snapshot of this today, a little after 4:30. We have a whole bunch of activity going on. Usually when there's cool stuff going on in the sky, a lot of people are posting. A few of the highlights here, the Observer's Handbook that Theo had mentioned. They come out with this every year. It's a fantastic source of information, plus what's going on in the year of 2025. I've got a collection of them, but like a lot of the information doesn't get old. So they're really good books. Theo will put up a button on our website, it sounds like, and then we'll figure out pricing and stuff like that. So make sure you get in touch with us one way or another. Also on the Google Groups, we have this post here of Comet A3 because the name is brutal to pronounce. So we're just going to go with A3 today. So some pictures from the club. Chuck's over there on the left. Connor's on the right. Let's see. Theo on the left. Brad Hill on the right. It's a very photogenic comet. That tail is amazing. And so I have to show because I was lucky enough to be in the Rocky Mountains yesterday. It's tough to be back here. Not saying I don't love you guys, but I was lucky enough to get out to the Rockies and catch this.
Nice.
Yeah, it was this is taken with my dwarf, so not even like my real camera. So this is one of those electronically assisted things. This is with my iPhone. And then one of the biggest issues is I sent this to my wife is she goes, it looks fake because there aren't any stars. And I went, yeah, there's not any stars. And the reasoning is because of this. That moon was ridiculous. And we could still get that beautiful tail. And to give you an idea, there's the wonderful moon. And this is an image. You can see the tail coming down. That's a shadow of my dwarf from the moon on the ground there. So it's pretty intense. So that's the reason why the mountains are so lit up. Somebody was accusing me of faking the photo because the mountains looked like they were in sunlight. But no, it's the moon. It's just ridiculously bright. So keep your pictures coming if you keep getting them. You know, the comet's gonna be around for a while. All these pictures with my cell phone were handheld, holding my breath for 10 seconds. So it doesn't take much. You know, the phones these days with the quality of the cameras are pretty interesting. And then one final thing with my dwarf, it has the ability to do telephoto as well as wide field. And so I was doing a time lapse on the wide field and flipped over to my telephoto and did a screen recording on my iPhone. And so I'll post a video link on YouTube, but it's essentially 4 minutes watching the comet sink below the mountains. And so it was pretty cool kind of watching it just disappear at that time. So, you know, I was lucky to be in the right place at the right time for that one. And then last little thing on our Google Groups, we had the Northern Lights show up last week. And again, in May, I was like, this is the last, only time I'm ever going to be able to see it because I'd never seen it before, and figured Iceland was going to be out of tourist money because people didn't have to go to Iceland to watch the Northern Lights. And then all of a sudden we get a new show, right? Ron Ladd put this out from, I believe it was at his place. You can see just the gorgeous colors there. Catherine Rexer shared hers. Chuck Schlim shared his. And just so many interesting colors. And I kind of mentioned that this was definitely different than the one in the early summer, because I would go out to the Natchez Trace right at the entrance there and park on that bridge. And I take my little phone out and take a picture north. And with the last one, it was just lit up, and you could actually see the purple haze there. And I didn't see anything. I was like, well, this is a bust. Maybe it's just not bright enough. And I started walking, kind of turning towards my car, and I saw it directly west. And so I pulled my camera out and took a picture, and then I chased it, and it shot all the way up across the top, Cassiopeia, Pleiades, and dipped all the way down into Nashville. And then later on, a flare came, or another pulse came from the north. And so I actually saw kind of like what Chuck did with the two reds on the side. And so this was my image. So you can see the one on the left, that was the one that was coming up over the top. And so on the right was all the way north. And then this is the image keeping on going. So that's Pleiades on the right. You actually see Andromeda right there in the middle. Cassiopeia is pointing at it. And then Nashville's on the left there. And so it literally just shot straight across the sky over my head. So you see one, definitely not going to be like the other. So it was pretty cool experience seeing this. And so I don't know the solar maximum, we still got a little bit of time left, so who knows how many more of these chances we're going to get. But if you get a chance, it's amazing. So pretty cool stuff. Let's see. Trying to think. Yeah, so if you're not on Google Groups, there's a lot of stuff posted on there, a lot of pictures you're missing out on. If you would like access, send us an email and we can get you in. On here in the upper left, you can see we have permits to get out on the Natchez Trace Parkway. So if you want to do observing at night, you need a permit with you. And we also have our equipment list if you're interested in borrowing a scope. So you can find those links there. I always kind of talk about the Night Sky Network. That's where we run our club through. They've just changed their website, and so it doesn't look like this anymore. So I need to update this. But I've started looking around and found some things that are a little bit more functional and easier to get to. They've started kind of making things a little bit, fancier and eye-catching. Here they posted about the auroras, and I didn't know what noctilescent clouds were. It's pretty cool, like highlighted blue clouds. And so they talk about the different lights you can see in the sky with different light patterns and stuff like that. So it was a pretty cool little article, and it was only a 3-minute read. So that was pretty nice to go through. They've started making, sorry, they have this banner up top, and it makes it easy to do outreach. And so if you haven't gone to a star party because you're feeling like you don't have much to talk about, there's always things to point out and stuff, things going on in the sky. And so like when you click on this outreach resource button, you get a beautiful star map. Here they're kind of showing you how to find various things. You can star hop, like finding Arcturus and then Vega, and then going over eventually finding the Great Square of Pegasus. On here, they also have a bunch of binocular highlights, so things that you can look at and point out with just simple binoculars. They also have current sun and moon data, so they tell us that, well, we're 100% full or pretty close to there. It tells you when the moon's coming up, when it's going down, things like that. On the right, they have a host of things. I clicked on the spot the station to see whenever it was going to be around next. If you're an early morning person, we're going to have a whole bunch of passes. Otherwise, we got to wait a while. So it's coming around in the mornings, but it's pretty cool that you can click on that and pump in your city, and it'll tell you when it's coming around. They also have, essential little notes. I felt like this was probably, they're playing on, hey, there's a comet in the sky. And so they put this list up here about comets and how big their nucleus are. It's going to vary in different sizes. They also have probably a rendition of Theo's Make a Comet activity on there, where you make a comet and skid it across the floor. So that's pretty cool on there. So if you're interested in doing some sciencey stuff, in this,
Do that. Yeah, maybe that's a Christmas party activity. Right?
Maybe. Yeah, we could do that.
I don't know if any schools out, if you remember the news article, but somebody did it for a bunch of kindergartners, and you know how it is. You get a group of kids, one person gets sick, next thing you know, everybody's sick, and they're blaming it on the CO2, which is that's ridiculous.
It wasn't you, was it?
And you really do get something that looks astonishingly like a comet.
Yeah. So one of the best things about this article was they brought back Comet McNaught and this awesome photo. They kind of had it whipping around over the Pacific. Yeah, no kidding, right? They get all the luck. Coming into the night sky planner, I hadn't really perused this much, but on there it keeps up to date with things, and so it has where the Comet A3 is. It shows you where to find it at. And so I thought that was a pretty cool addition. Oh, I don't know why that automatically skipped forward. About there. Yeah. They had a YouTube clip that said potentially bright comet. So at least they used the word potentially. So they weren't saying super bright comet, naked eye viewing. But also in there, they had this. They had a video talking about the comet. Apparently, there's another comet coming around. It's a sun grazer. It's Comet S1. And if it survives its trip around the sun, it's apparently supposed to be really bright in theory. But they're saying that it's already starting to look like it's disintegrating. So may not be much of a chance. If we do get to see it, it'd probably be around Halloween, because apparently it would be Southern Hemisphere right now. But on Halloween, if it lightens up, this is what their prediction is, going up to -3, -4, which is pretty bright. But again, there's a good chance it's not going to survive the trip. But it'd be interesting to see, especially over Halloween when you're taking kids trick-or-treating. So not holding my breath on that one. Don't want to be disappointed. In terms of past events, we had a private star party that Steve hosted on the 19th. Pretty good turnout, Steve. Couple people, yeah. That was at one of the new places that we're looking at, and so that was set up through the Google Groups. So if you want to be in tune with these things, make sure you're on there. On the 21st, we had the Astronomy at Nature Fest. Chuck, were you there?
Yes, yeah, I had that set up.
Yeah, how'd that go?
Really well. I think they said they ended up with oh, I don't remember now, a couple thousand people, I think, and just did solar astronomy all day.
Well, at least it was sunny, right?
Yeah, yeah, hot. September
Awesome.
now, hot.
Yeah, and just to send more props your way, you were out at Liberty Creek with Danny. So thank you guys for doing that. How was that event? Pretty good?
That was pretty good. They just said today they had 522 people. Figured about half of them came out to our to the telescope and had a little bit of exhibit and gave away some space astronomy books and such. It was only from 5:30 to 7, and so Venus popped out about 6:45. So we were at least able to show it for a little bit.
Well, that's cool. Getting kids' eyes on telescopes is always a good idea. So thank you again, guys, for going out and doing that. October 12th, we had the public star party. I knew there were people out there because we got our wonderful picture by Bud of the comet coming through here. How was that? Were there a lot of people there?
Quite a few,
Quite a
good
few.
turnout.
Yeah. People
Yeah.
get to see. Did people get to see the comet, or did
Yeah,
when did it go down?
well, let's see, that picture was taken 18 minutes after 7,
Gotcha.
so it was shortly after 7.
Well, I
It was
think
pretty close to the horizon at that time.
yeah, that was the first time we could really see it really good. I know I tried getting out there in the mornings and I just couldn't do it. It was a combination of clouds or just me being too tired. So
Does anybody remember? Did
go
anybody
ahead.
visually, just with their eye? We saw it through the telescopes. I don't know if anybody saw it visually.
Binoculars were really good, but I think once you knew where it was,
Yeah.
You can see it.
especially if you could do averted vision, you could just convince yourself of it.
I can tell you that at 9,000 feet elevation, it was naked eye. I didn't have much light pollution to deal with, and so I could see it naked eye. I actually caught it naked eye first before pulling the camera out because I saw it lancing through a cloud. And it was pretty wild.
I drove
I
on
saw
it.
it naked last night out
Yeah.
in Phil underneath two bright parking lot lights.
I
Yeah.
drove 2 nights ago past 840 and I saw it naked eye through a cloud. I
Yeah.
mean, it was just hazy, but I
Yeah.
could still see it. It was pretty dark.
Has anybody seen like the magnitude right now? Like, I don't know. I haven't seen any actual numbers on it. But it's gotta be pretty bright.
To take because
Yeah.
they're diffuse, they're not point sources. Like
Yeah. But one of the cool things about this one is that anti-tail, right? Like it's coming in front. Like I know you couldn't see it on this picture, but you could definitely see it pushing forward. And I was like, what's going on with my phone? Then I look at the dwarf, it's got the same thing. So it's pretty cool trick of lighting. Things upcoming. We're again talking about November already. We have a private star party. Yeah.
Sorry, can I interrupt?
Yeah.
I just wanted to mention on Saturday, I also did the STEAM Festival at the Murfreesboro Discovery Center.
Oh, cool.
And they had a couple hundred people there, and I was doing the same solar sunspot viewing kind of thing there.
Yeah,
But that was
yeah, go ahead.
that was a nice event.
Yeah. It's really good that we're in an active cycle, right? Because I imagine looking at the sun without sunspots, I remember is kind of not necessarily exciting. So
Yeah.
we're looking into these. Yeah. Makes
Yeah,
these
a lot of big.
All right. So again, November 2nd is our next officially scheduled something. It's private star party for members. It's out on the Natchez Trace Parkway. Sunsets at 5:49, and then essentially, if you can get there before the sun goes down to set up, that way you save people's eyeballs from car lights. It helps out, but if you can't, that's fine. We understand. Sunsets at 5:49. The permit is located on the Google Groups, and so they ask that if you are out there to have a copy of it. It doesn't have to be printed, maybe on your phone. So make sure you have that on you, because when the Rangers stop you, and they usually come by, they would like to make sure that you're supposed to be out there. If you're out there all night, you will possibly lose or gain an hour because on November 3rd, which is Sunday morning, we hit the fallback in daylight savings time. And so notice what happens to our sunset. We start hitting in the 440s and 430s at our next couple things. So again, people not necessarily like losing the daylight, but as an astronomer or somebody likes looking at the sky, it gives me a whole new a whole extra hour in there. So the next public star party is November 9th at Warner Park. Because everything's getting a little bit earlier in terms of sunset, Warner Park has their event starting at 6. So make sure if you want to do that you're scheduled appropriately. And then on November 30th, we have another private star party at Water Valley. And so that'll be after our next meeting. And so we'll chat more about it there. Is there any other upcoming events that people have scheduled? Okay. Coming up in the night sky, I always like to put this out there, just because there's always certain things coming on. There's a lot of kind of groupings. Venus and Antares might be pretty cool. We have a couple meteor showers that are potentially on the books. The Orion meteor shower is probably one of the more famous ones because it comes right out of Orion or near Orion. And so you're looking for the radiant. Now, not saying that all of them have to come from here or look like it, but this is typically where they start coming out of. On here, though, I wanted to point out these. As I mentioned, the moon can be a pain and shake my fist at it every time I'm trying to take pictures of my night sky objects. But as Theo has mentioned in our Google groups, there's a lunar observing program that's put on by the Astronomical League. And so I wanted to put this up there, and I threw the website on here. So if you wanted to check it out yourself, there's some requirements that they have. You basically have to, there's things to do with your eyes, things to do with binoculars, and things to do with a smaller scope. They ask, how would you like to use it, manual or device aided, and they like it manual. So no remote telescopes. So can't do it with my dwarf. But they are allowing visual and imaging. So you can do a couple things there, and it's essentially about 100 observations. And so we're starting at the full moon right now. And so if you wanted to get started on this with the rest of us in the club, there's a lot of cool things to see. And then you submit it online. As Theo mentioned, they'll send you a pin. Do they send a certificate too?
Yeah.
Yeah. And so we all love pins and certificates. Yeah.
If you haven't started in these programs yet, an easy place to start is now. Because if you do any outreach, then you can.
Oh, yeah.
Just keep your time in place and all that.
Yeah,
And fill it out, fill out the form, send it in, and you get a certificate. And it's what, 2 levels, I think? 3 levels.
Yeah.
Cool. Yeah. Yeah, because I'm always looking to find ways. I know Theo mentioned that she's wanting to get more familiar with the moon, and I'm also interested in that. So this will help out, right? So there's some cool things on here that I'd never even heard of, right? So I'm fairly familiar with the top 4, but those ones down below, right? Man in the moon, woman in the moon, rabbit in the moon. I never heard of that.
Oh, man, once you see it, you won't be able to.
So like these are the things that I'm interested in, right? So the frog in the moon, man carrying sticks in the moon, right? So that one's full. So now I'm gonna have to go out there and try and get that out of the way. So there's a whole bunch of features out here that I'd never heard of. So I'm excited about that. And then they also have this optional objects. And so there's things for each class. I like the one, the bottom one, the naked eye, find the thinnest phase by which you can read newsprint. And I'm like struggling in daylight. And so I don't know where that's going to go. But there's, sketch a lunar map. I like the bottom one of the telescope as well. Measure the height of a lunar mountain. Need to calculate the sun's elevation at the mountain and estimate the shadow length. That seems pretty intriguing. I have a little bit of a math interest, so I imagine that would be pretty cool to do. So if you're interested in, doing something else besides shaking your fist at the moon, maybe learn about it. It seems like it's a pretty cool program. And so, we'll figure out a way to maybe we can do it as a group, like, hey, we're going out and look at the moon. We've seen this, this, and this, and, let people know what's out there and potentially what they could see. they have other observing programs and stuff as well. And so this will be the first one that we're kind of trying to kick off this way. And I'm sure maybe the urban observing program is another one to go after since light pollution and everything around here. So with that, our next month's speaker will be our very own Keith Rainey. He's giving the All I Want for Christmas talk. And so he'll go through and get ideas ready for you to share with your loved ones. Or if you have a loved one, this would be a great place to shop for. And so the next meeting is November 20th, and it'll be here at 7:30, weather appropriate. So with that, that's all I got. Does anybody have any questions about any of the stuff we covered today or anything else?
Do we have any visitors today? Anybody who's not a member of me today?
You already joined. That's what I wanted to talk to you about.
What other criteria I could try? Carry this one. And it could just be interest too, but, okay, NASA sends stuff. And I gotta get rid of it somewhere. All right, the 97 Cassini. This is modeled after an ad that was done for the Corvette years and years ago. But somebody redid it to do it for the Cassini spacecraft. Who would like this? Do you have an observatory wall this needs to hang on?
I mean, I'm always interested.
You're fine.
I mean,
Give it
I
to a
can't.
student.
Yeah.
I think, you know, but anyway, I've got two of them. And I have more at home. I just brought two tonight. So. I don't think I have any more left. Last year for Halloween, I got some gamma ray ghouls.
That's cool.
Whenever JPL cleans out their closets and they find these stashes of posters that got made, we'll get a little email that says, first person to say yes gets this pile of this, you know. So anyway, this wasn't my first choice, but it was good. And then I do have posters tonight if anybody wants to come.
Very cool.
All right.
Well, with that, we'll go ahead and adjourn the meeting. Thank you, everybody, again for coming out tonight. Really appreciate it. Hopefully see you guys. Oh, question?
Telescopes or additional copies if anyone wants to, they can take it.
Cool. Well, thank you for that. I appreciate that. So if you didn't hear, he's got some Sky and Telescope magazines for people if you're interested. Awesome. All right, we'll go ahead and call it there. Again, thank you, everybody, for showing up. Hopefully see you guys at the Star Party. If not, next meeting. And everybody have a safe week, a safe month.
Oh, how many Zoomies did you have?
4-ish.
I'm very new to all of this.
Oh, fun.
Okay.
Me
All right.
too, oddly enough.